Hello, my dear students, and welcome in the Indoor Environmental Control course. I am Associate Professor Kareem Galal.
This time I will continue with the electrical lighting system and explain the Lumen method. The title of this lecture is the Lumen method. Now we want to calculate the lighting level at the working plane from a uniform light, which is the light from fluorescent lamps, not directed lights such as the spotlights. But what the definition of a uniform lighting physically? The criterion for uniformity is that at the point of least illuminance it is not less than 70% of the maximum. In practice, this is provided by limiting the spacing of luminaires to 1.5 times the height of luminaires from the work plane, i.e. the mounting height. The Lumen method, or total flux method, of general lighting design is applicable where a regular array of luminaires produces a uniform lighting. For a given system, the total lumen output of lamps is calculated, which is referred to as the installed flux, phi, and the flux received on the work plane will be as the above formula. Where MF is the maintenance factor, to allow for the deterioration of the lamp, luminaire, and room surfaces. In the absence of more accurate data, this is taken as 0.8. UF is the utilization factor, and the method hinges on finding the appropriate UF value. The magnitude of UF depends on the following factors. Properties of the luminaire: an enclosed luminaire or one with less than perfect internal reflectance will have a value much lower than an exposed lamp. The DLOR, downward light output ratio, of the luminaire. Light emitted upwards will reach the work plane only after reflection from room surfaces, and some of it is absorbed in these surfaces. A larger DLOR normally means a higher UF. Reflectance of room surfaces, which is more important if the DLOR is smaller, but influence the lighting even with high DLOR values. Geometrical proportions of the room, as expressed by the room index, the ratio of horizontal areas. LW2 and vertical areas. L and W, 2 where is the mounting height, from the work plane to the luminaire, the multiplier 2 cancels out. Direct ratio, how much of the downward emitted light reaches the work plane directly. This has a low value with a narrow and high room, small room index, but a high value for a wide room, large RI, and downlighter type luminaires. If an installation is to be designed, the previous equations are inverted as the following. If an illuminance E is required, this is multiplied by the work plane area to get the flux to be received, phi r. The type of luminaire is selected and the UF is found. The MF is taken as 0.8, higher in very clean spaces, lower in dusty or dirty situations, or in the absence of regular cleaning. Thus the flux to be installed will be as this formula. Combining these steps, we have a single expression. Then we have to work back, divide the phi I by the output of one lamp to get the number of lamps required, decide whether single or double lamp luminaire would be used, devise a luminaire layout, a ceiling plan, and check the spacing limits. Example. A general office space is 12 m x 9 m and 2.7 m high. The illuminance required, from tables, is 400 lx. Reflectances are: ceiling 0.7, walls 0.5. If the work plane is at 0.8 m and ceiling mounted luminaires are to be used, then equals 2.7, 0.8 equals 1.9 m. Therefore, the room index will be as the following. We select an enclosed plastic diffuser type luminaire, which has a DLOR of 0.5. From the data sheet we locate the column headed row ceiling 0.7 and within this the subheading for row walls 0.5. There are lines for RI 2.5 and 3, so we make a note of both UF values of 0.55 and 0.58 and interpolate, which is to be added to the lower value. Thus, UF equals 0.56, 2 decimal precision is quite sufficient. From pre-equation the flux to be installed will be calculated as following. For uniformity the spacing limit is 1.5 equals 1.5, 1.9 equals 2.85 m. From tables we see that 1200 mm fluorescent lamps are available from 1120 to 2800 Lm output, and select a medium quality for good color rendering. The colorite lamp with a flux output of 1800 Lm. Of these, we may need 96429/1800 equals 54 lamps. We can have twin tube luminaires, so we need 27 of these. We may have 7 rows of 4 luminaires, so the spacing may be 1.7 m in the 12 m length, 0.9 m from the walls, and in the 9 m width, the spacing would become 2.25 m, giving just over 1 m between ends of luminaires. Both are well within the 2.85 m limit. Thanks for following me, and I hope that I have explained the topic well.
This material is copyrighted. Associate Professor Kareem Galal 2021. All rights reserved.